Hey, this session was originally about composefs-rs, but then I decided to hijack it because testing is kind of interesting, and I really am looking forward to feedback that I might get from the people here. I'm Allison. I work in the cockpit team at Red Hat. And working in the cockpit team at Red Hat means that I spend a little bit of time developing cockpit and a lot of time working on tests. So what is it? Yeah, it's like a virtual machine runner script, like qemu. It's got these scary command line arguments. Nobody wants to do that themselves, so basically everyone has one of these. And yeah, like a lot of these are, you either have it locally for testing on your own machine, or you have something in CI, which is like you have your CI images that you use for testing. But generally, it's limited to a particular kind of environment that your CI images have, right? Like you'll know what the root password is, or you'll have a key in there. That's what we do in Cockpit. We seed it with a key that is the same in all of our images. And our testing framework has the private side of that key. A lot of things we'll do cloud init or ignition or something to initialize the images. I sort of wanted to try and do can we make something that's not depending on all of this stuff. So basically, I want to be able to get a stock image that I download from Arch or the Fedora project or whatever, just their standard QCow images, and then be able to do stuff with it, right? And since this is for the Cockpit project, the way that we write our tests is we have these tests they're currently in unit tests. We slowly try and move them to PyTest. And it's very much okay, we need a browser and we need a machine. So for us, we want to execute something on the machine, see if it did something in the browser. And we sort of drive this process from outside. But even maybe more basic, the reason you want to drive from outside, yeah, and I wanted to do this without this, without these guys, without those. I get to the other point in a second. How does it work? That's why I'm here talking about it. It's basically systemd on the inside, right? There's all these things that systemd is doing for us that allows us to basically be able to connect to any VM image that has a recent version of systemd in it. So you can inject these credentials into the OS. You can do that with OEM strings or this fw-config command line argument on qemu. And that becomes available in /run/credentials at system. And then you can give systemd units access to these credentials. And there's some ones that are sort of there out of the box. This one is really useful. This will basically when you're starting up and you're hitting unit targets and when your system is ready, it'll connect to a vsock of your choosing, so probably outside of the VM, and say, hey, here's the unit that I just started. So that's really useful for testing, knowing if the image is booted yet. And then once it's booted, once we hit sockets.target specifically, we know that vsock listener has been created by the systemd SSH generator. And we can connect into that using vsock. And that's really cool because it means you don't actually need network. This thing doesn't have an IP. It hasn't configured the network. It hasn't done DHCP. And you can already connect over SSH using, again, this unit that's generated by that generator. This thing is the super awesome feature that got added some time ago. Basically, if you put this credential in, then SSH will accept logins as any user if you present that private key that's in that authorized keys file. And that's the thing that sort of allows you don't need an authorized key file in root home directory. You can SSH in, and if you present that key, you get in. Yeah, and then testing, the way that it's working is that it has this SSH control socket on the host that we can then use to issue further commands without authenticating. Yeah, and in the guest, what do you need? The ephemeral keys is pretty new. It's in systemd 256. And there's a lot of issues with host OSs that either it's saying SE Linux is upset because why is it trying to access this path that I don't think SSH should normally be accessing? Or a funny one I saw is that the root directory has group write permission on some OSs, and SSH thinks, why is this parent directory of this thing where I'm getting the SSH key from writable by the group? I ignore this authorized keys file. What can you do? You can do SSH root key provisioning as a fallback. That's from 252, so that'll get you some more ones covered. That involves, unfortunately, writing a key into root's home directory permanently. If you're doing snapshot mode booting, where you throw away the image as soon as you're done, that's probably OK. But for something that's an ephemeral key, permanently writing it to the image is obviously not ideal. After that, there is support for Cloud Init. We can inject stuff that way. We have a lot of really old images we test in Cockpit, and they have really old systemds that like don't even have credential support. So for those, we need to go a little bit further back. And yeah, basically, like there's in the test.thing repository, there's a bunch of workarounds that like you can add the SSH vsoc unit into an older system, and that'll work with RHEL 8, for example. And that'll get you, if you can add these things to your older guests, and we have like Cloud Init support for that, you know, add these files, reload systemd, enable it, then you can actually use the vsoc stuff with older OSs as well. And yeah, I've been filing PRs with a lot of distros. Like I've been filing against Debian, Arch, Fedora, just like generally fix this stuff so that when I download your images, it actually works. vsoc is basically, and I just go over it really quickly if you don't know it, it's a way of putting a PCI device into a virtual machine. It's kind of like a network interface, but it doesn't work like a normal one in having an IP address and stuff. It's sort of a direct connection between the host and the guest. It has ports. You can like bind port 22, stream socket for SSH, and then you can connect into that. On the host, it's kind of, so QEMU has this issue. It also likes to use vsoc on the host, which is just generally a bad idea, because then each machine needs like its own CID. It's globally accessible. There's a much better way of doing it using this multiplexer socket that's speaking over AF Unix, like in whatever private directory you have access to. QEMU doesn't support that directly. There's a workaround. I really hope they support that eventually. There's an open bug. And yeah, systemd SSH proxy, shout out to that. This is a really cool tool. It can connect directly to those global vsoc CIDs, but it can also connect to Unix sockets and speak this multiplex protocol. Basically, it opens the Unix socket, it says connect 22, and then it's speaking to SSH on the inside. And it's designed that you use it as a proxy command with SSH, and then you just SSH, and then you get to the SSH on the inside. Yeah, so I mean, this entire project was sort of inspired by mkosi. We had a conversation about a devconf, like what would it look like if we turned this into an API? And then I started thinking about, okay, probably like let's do this. And also it basically is speaking to the same API as systemd VM spawn. Maybe somebody will write one of these in Rust at some point. Like I really see like this space, if we define this common set of things like, okay, if we have these things that systemd do, then there can be lots of these, and they all speak to the same set of requirements, and then all of the distros implement those requirements. That's kind of what I want to drive towards with this. Yeah, so going back to the drive from outside testing I was talking about earlier, it's useful for us because we do like machine and then browser and then do some more stuff with the machine. But it's also just like as a matter of principle, this idea that you would take a whole bunch of testing code and then make an image with it and then tell that image to run the tests for itself, I don't really trust it because, thank you. You know, you're doing assertions inside of the thing that's under test basically. And you could imagine like, okay, let's do a buggy kernel that like wait PID is always returning 0, right? All my tests are passing, everything's great. I really think that if you're doing tests on a virtual machine, you're testing something about this image, you really want the assertions outside of the virtual machine. So yeah, here's what you can get it from. You can do pip install test.thing. It's on Codeberg, the repository. And the one thing that really makes it useful for Cockpit and is how we intend on using it is that it's just a single file. So like you get your testing.py, you copy it into your project, and you basically use it as a vendor library. It's only standard lib in terms of Python dependencies, but obviously you need a couple of things in your path for it to work properly. This is what the API looks like. It's just like a standard async IO context manager. The IPC directory, it's a little bit of an implementation detail I won't get into, but it's where all of the like sockets and stuff live. You just give it a VM image, and then sit equals true is an interesting thing here. I'll show that on the next slide. And yeah, it has like a sort of a quasi-pathlib API, but with async stuff. You can execute stuff. Yeah, and that's how it works. And when you enter the context manager, it will wait until the machine is booted, and then let your code run, and then when you exit, it'll tear the machine down. This is, if you run that code, you might have noticed that here we have like world is small, and then we assert that it's big, so that's going to fail. you get this, okay, it failed, but because we had that sit equals true, it does this nice thing for us. Okay, the guest is still running, I'm gonna wait for you. You can connect with this sshtt.0 and you can get into the guest and see, okay, what went wrong with my tests. What's sshtt.0? You can add this to your SSH config, and this is just like a basic way to tell SSH, okay, if somebody connects to that, then forward them to this thing in the XDG runtime directory where you'll find the SSH control socket. And that's also a cool tool because you can like, SCP stuff to TT0:, and then it'll land in the machine. Yeah, you can do it from PyTest pretty easily. It's just a context manager. You use it in the same way. So here's a test. It'll run. It's doing something else. You'll notice that on the other side, I had like a shell for m.execute or vm.execute, and here I do individual arguments. If you do individual arguments, then you don't need to worry about quoting. Like if there was like a space in that file name, then it would get quoted properly and everything. You can also do it as a fixture from PyTest. This is showing specifically scope equals session on the fixture. You can see that single VM invocation is going to be used for multiple tests. So if you're worried about how long it takes to start up the VM, then it'll run the individual tests in the same VM, hopefully with each test not modifying the VM in a destructive way. This is something we use in Cockpit a lot for saving time on testing. We call them our non-destructive tests. And yeah, that's what it'll look like if you run it. It's just, okay, test true, passed, test false, failed. Why did it fail? Well, we ran this SSH command, and it returned a non-zero error code. It returned 1. And yeah, it did that all in 8 seconds, so it's definitely sharing one boot of the VM there. It also has a nice CLI. If you just run TT, this drives Martin crazy because he says I'm like namespace squatting, and I should not have name that's only 2, but I checked it, and there's not really anyone using that one. It just runs it, right? So it's like SSHing, but instead of SSHing to a host, you SSH to a QCOW, and then you get access to it that way. And additionally, like you get that TT0 thing. So again, as I said, if you want to add extra files, SCP whatever file to TT0:, and then it'll land in there. You can also do like running commands on it. Like if I wanted to like, extract some information from a VM image, I could do that. And you can even use that in like pipelines, which, I mean, this is obviously ridiculous. Why am I running grep inside of a VM? But maybe it's like a better grep, I don't know. And you can just compose commands like that. It's kind of, I mean, it is SSH, and it kind of works like that too. Like you can use it in composable ways like you would use SSH. Yeah, here also, this is like sort of inspired by what we do in Cockpit. You can do the -L is the same sort of SSH for port forwarding stuff. So we say we want like local port 9091 will go into the machine as 9090. And by the way, can you start the Cockpit socket systemd unit when you start up the machine? And yeah, so from there, like if I wanted to connect to Cockpit now, then I would be able to do that on my localhost 9091. Yeah, I'm designing this API document. It's kind of like, I don't know if anybody's really interested in this, but maybe it'll load, maybe it won't. Maybe not. Yeah, here it is. Basically, I want to like, if we could define all of this stuff, that would be kind of cool, and then point distros at it, because like, 5 minutes? I'm getting a lot of people like asking me like, why should I support this in the distro? Like, who says that this is the way of doing things? I feel like if we could get like a couple of different consumers of this to say this is how we want to do this stuff, then that would actually be pretty cool. Yeah, and as you can see, it's on Codeberg. Just a friendly reminder that GitHub is still proprietary software. And yeah, we're probably going to get burned one day soon, so I try to avoid that. And yeah, ideas, like what can we do going forward? Hardware hot plug, this is a very important thing in the Cockpit project. We do like, add a network interface, make sure that it appears in the web interface in real time, hot plug some storage, stuff like that. This is definitely part of why we wanted to do it this way. And then, of course, you would just drive that through the machine object, like execute command, add hardware, execute other command, whatever. Cloud hypervisor, again, I mentioned that qemu has this outstanding issue for the way that vSOCs are implemented. Cloud hypervisor is also a little bit faster to start. It can boot more directly, even using the ESP. Might be something worth looking into. Its hardware support is not as cool as qemu. It doesn't support like a whole bunch of cool legacy devices. Like if we wanted to test how smart attributes work in Cockpit, for example, that could be a problem. Just an idea. Booting a directory, it was an idea proposed to me at the party last night that if we pointed at like, here's a subdirectory that I can mount via vert.iofs inside and use that as the root directory, probably like, patches accepted. I think it wouldn't be too much work to get that going. It would probably be pretty interesting that you don't need a QCow. And yeah, Martin just hates the name. He really, like, testing? Are you crazy? Like, what's wrong with you? Yeah, that's it.
The competition.
So I said booting a directory was easy, but then I realized we do some horrifying sub-UID hacks to actually make it work, because you need a full writable range to be able to write to. So you need to run vert.iofs within that user namespace with the sub-UID stuff applied, because otherwise your VM can actually write.
Is that how that worked?
Right.
I was like oddly optimistic when I heard in the talk this morning about
easy,
like, oh yeah, this works great for vert.iofs.
But like once the whole foreign UID thing is in, I think it would also perfectly easily work for doing it with vert.iofsd somehow.
I mean, there's also kind of like vert.iofs is nothing more than fuse, right? And normally it's just implemented by reading the local file system. You could add some kind of a UID remapping thing to that if you wanted to, I guess. And plus, also, I heard that all system images are supposed to only have files on by root:root in them anyway.
Yes, but then your thing boots, and then it wants to write something to /var that is owned by some like user that the daemon is running as. If you could have like a single user mode for booting a system, or like you
I don't know, like what if you run like the vert.iofs server like under fake root or something, and then I feel like that's like half of a chance that it could actually work.
So it has UID squashing, right? You can like literally tell it everything that you come in, just write it as this user on disk, but then like stuff in the VM is just going to start failing horribly, because it's going to stat and it's going to be a different UID than it wrote the thing as.
I think it'd still be worth a shot to try implementing that feature.
You know, you joke about vert.iofs under fake root, but Yocto has pseudo, which is basically that. It's a server that has ID mapping. It's terrible, don't use that. I'm sorry. Any other questions? Ah, yes, sorry, I couldn't see.
Not directly a question, but I think it would be a good idea to have a little bit of a look at what you proposed with regards to the interfacing, because it seems that pretty much everybody is rolling their own VM tool in one way or another, either for like, I don't know, boot my kernel that I just got from this directory, or execute a test, build something for me. So it would be great to deduplicate some efforts, and maybe the UAPI group is a great vehicle to further these efforts.
Yes, I put it on the agenda for tomorrow for exactly this reason. And again, like most of the things in here are basically just like have systemd inside of the guest and have the features enabled and not broken by the way the distros like package SSH. One extra thing that I think is kind of useful is this one. This, you can kind of do this with repart. Cloudinit also does this. I think this is actually really important, because one thing we do is we download the cloud images. They're generally pretty small. The first thing we do is resize them and then boot it. And if something's not resizing it from inside, then...
I have a PR open to do that in repart, but it doesn't work. It breaks some other stuff. But the truncating during the partition on the first boot.
And everything I hear with repart, why can't you use it, is, oh, we need LVM support.
So just to clarify, like for, let's say, a modern, like current operating system, say Arch or so, you don't have to do any modifications anymore. That's the idea, right? Like all the write extra unit files, etc., what you mentioned, that's only for supporting older systems.
Yeah, like the goal is that eventually every image that gets released by a distro would implicitly support the spec and then just work with testing, right?
Right.
And because it's so, I mean, you can say, question whether systemd is vendor neutral or not, but that's the closest thing to vendor neutral we have in this space, right?
Right. I mean, I noticed you also need to add some units to SSH and so on, but I think that's also already upstream, right? So this is also only backporting.
Yeah, like this is all standard stock behavior of the systemd SSH generator.
Just a comment, don't listen to him. The name is great.
Thank you.
So does PyTest get confused if anything goes with the execution on the VM?
Yeah, so the way that that works is that everything is in an async task group, if you know this in Python. And all of the subtasks, like the qemu task or like the SSH control socket task, are all calling like wait asynchronously. And if any of them exits unexpectedly, then it will abort the entire task group. So if it notices that, for example, SSH disconnects unexpectedly, then it'll bring everything down. And if you want to reboot, there's like a way of doing that. You enter into a special state where we like known deterministically terminate that SSH, reboot the machine, wait for it to come back by the SD notify messages, and then return to you. But at any time if something disappears or exits, then the whole thing comes down.
And can you extract logs from the like journal CTL output from the machine?
I don't have specific support for that, but I'd be open to that.
I mean, it would be nice to automatically connect, like instead of standard output from the script, you get the standard logs from the machine.
So you're talking like journal CTL-F or something? For sending the journal?
Yeah, but the like the way that PyTest works is that it prints standard output and standard error from the code. I mean, it captures it right when you run locally, and it would be kind of magic if you could do that for the remote stuff that gets logged.
That's a pretty cool idea. Yeah, and from Dan, he mentioned that you can set a credential to send the journal output to. Can you send it to a VSOC or? Yeah, you can send journals
gateway
to VSOC.
stuff? No.
That's actually a really cool idea, and I think I'll probably do that.
Yeah, so you can set the credential, and then you have to run systemd journal remote on the host to receive it. I don't know if we have anything to automatically like tail it to standard out in that case, but that should be possible to that. That would be cool to have.
It's actually the only issue I have open that I haven't fixed yet is like extreme debugging support for like, switching on all the things. But I was planning on using the serial console for that, but knowing that you can also do it that way is really interesting. I was spending a lot of time debugging like early boot problems and security modules that the kernel wasn't coming up properly.
Yeah, I was just curious as a kind of straw poll to the room, like who has something like this, a VM runner in their project currently? Yeah, that's about what I expect.
Yeah.
Thanks.
Any other questions? We got 1 minute left-ish. 1 minute. Any question? Any comment? Yes. Competition again.
Your API document gonna list the patches people need to backport to OpenSSH to actually get this to work?
Yeah, I mean, like, so if you go here, again, the network is really, really bad. Maybe Codeberg is not such a great place to put your code. I'm going to blame it on the venue network, but like I have a list of workarounds that are hosted in the repository, and it's basically like the SSHD vsoc socket, the SSH vsoc service with the @ You need some seriously heavy SE Linux fixes on RHEL 8 in order for it to think that SSH should be listening on a vsoc at all. And also, I have a little script that basically replaces the VMM notify support on systems that don't have that as well. And that, like for every image we care about in Cockpit, which is really a lot of them, going again all the way back to RHEL 8, those 3 things are basically all you need. And yeah, I have a workarounds directory in my repository if it would load.
So have you backported all those OpenSSH patches to RHEL 8, or how do you handle that?
So there's these DNS things you're talking about, right?
The DNS.
Yeah, no, just haven't. And for some reason, they're not an issue on RHEL 8. I don't know why. For a large part, I've just been writing like unknown 0000 into etc hosts, which, yeah. So the thing here is that if you connect to SSH on vsoc, the SSH upstream project doesn't know how to figure out what the IP address of it is because it thinks that you only should be connecting on IP. It tries to query the kernel, it can't figure it out, it writes the string unknown, and then other parts of the SSH code use that as if it's a real DNS name, which results in various parts of the system trying to DNS look up unknown, and then you have to wait for 30 seconds or whatever. It's totally stupid. SSH should just take the damn patches, but distros end up carrying them.
So first topic for the UAP group tomorrow, OpenSSH fork for Linux.
Yeah, I mean, this is Dan's passion project, maybe, I don't know. I feel like maybe we could do better things.
Yeah, that's all the time we have, so thank you very much for your talk.